Welcome to the video on market basket analysis. So what is market basket? So it is a data mining technique which deals with the correlation between different items. So it works on association rules. So what it does is it works on frequently occurring items in a data set, and then it generates association rules. What it means is it generates rules to show whether one item is dependent on another or not, something like that. We'll see it in details later. So basically it boils down to the understanding of how two or more events are correlated, and these relations help us predict the occurrence of one event based on the occurrence of another event. It is mainly used in retail business for strategically promoting one item based on the sale of another item. So what they do is they look at the fast and slow movers among all the items in retail business, and then how the products are being purchased together, which products are being purchased together. Then they identify those products which can benefit from the promotions, and then they design their store layout in such a way that also there is also strategy involved in how you lay out your store, depending on which products go together, which products don't go together, something like that. Then you plan sales and promotion for certain products which can benefit from the sales and promotion. So what are the benefits of MBA? See, we'll explain this with example. Let's say, the customer comes to your store and it buys product A, but then you also have product B, but this customer buys product from another store, not from you. So there is a opportunity lost. So you can look at it and understand why it is happening, analyze. So MBA allows you to understand that actually. Then for example, if you have a car showroom and you sell car, people come buy car from your showroom, but when it comes to audio system for the car, they go to another outlet, another shop. So there also you're missing an opportunity. So this analysis mining helps in that. So a customer makes a lot of purchases and suddenly buys product X. Now this product X has been lying on a shelf for a long time collecting dust and nobody is buying. But suddenly this customer comes, he purchases a lot of things and then he buys this particular brand of product. So what MBA will allow you to understand here is that it'll let you contemplate whether if you get rid of this product X of a particular brand which has not been selling for quite some time, and if you get rid of this and replace it with some another brand, will it not spoil your relationship with this customer who purchases so many things and then buys this particular brand? So it helps you in that. Then again, it helps you identify the brand loyalty of customers and purchasing patterns. So let's look at one example here. So there are so in retail business, normally they store all the transactions, right? So there are examples of transaction one where you have this bread, chicken, and milk. So a customer comes and buys only these three products. So it becomes transaction one. Another customer comes and buys meat and cheese together. Third customer comes and buys meat, chicken, and cheese together. Fourth customer comes and buys meat, chicken, baby food, cheese, milk together. Then the fifth customer comes and buys chicken, baby food, and milk. So you see, and the sixth transaction, you have chicken, milk, and baby food. If you see this, chicken and milk are going together, chicken, milk going together, chicken, milk, and also baby food, they are going together. So this is how you form association rules. You see these products are going together. Chicken milk, especially here, chicken milk, and in these three transactions, chicken, milk, and baby food, all three going together. So and then meat, cheese. So these are the way you look at this association rules mining works. And thanks to barcoding technology, which allows store owners to store all these details in a database. So association rules algorithm, how does it work? So first what we do is we identify all the frequent items and count their co-occurrence, like how those multiple items are happening together. So this is the first step. Then we create a subset of frequent item sets. That means uh, the item sets which are coming together, being sold together. In a store example, supermarket. items which are getting sold together, purchased together. So we create the subset of those frequent item sets. Then we develop, based on these, we develop association rule. Here, if A occurs, then B occurs as well. A simple example. So A is known as antecedent. This is antecedent. If A is selling, then B is also selling along with that. And B becomes consequent. So antecedent and consequent. Example is meat, cheese. We saw in the previous example, right? So meat and cheese have sold together many times. The above process is repeated this for each frequent item set until convergence, no such item set found. So this is how it works. So important metric to perform association rules are support and confidence. What is support? A is antecedent and B is consequent, right? So the number of records containing A and B together in the entire data set divided by the total number of records, right? So number of records containing A and B together divided by total number of records. So that becomes your support. Confidence is the number of records containing A and B divided by total number of records containing A. That means of all the records containing A, how many of them also have B? That is what it means, confidence. So example of support and confidence. So let's see. So this is one example here. I've just created random data here. Transaction 1, t-shirt, umbrella, mug, spoon. Transaction 2, t-shirt, umbrella, mug, spoon, broom, and pen. And third transaction, umbrella, spoon. And transaction 4, t-shirt, umbrella, mug. So we want to calculate the support for mug as antecedent and spoon as consequent. So you see mug has appeared in 4 transactions. 1, 2, no, sorry. So this is support, right? So mug and spoon, how many times they have appeared together? So mug, spoon, 1, mug, spoon here 2, and that's it. So 2 times of all the 4 transactions, they've appeared together only 2 times, right? So that is the definition of support, right? And that divided by total number of transactions. So there are 4 transactions, so 50% of the time they've come together. That is support. Confidence is again out of all the records where mug has appeared, how many times spoon also has appeared. So first let's see how many times mug has appeared. 1, 2, and 3 times mug has appeared. So this is the here, and how many times spoon has appeared wherever mug has appeared. So 1, 2, only 2 times. So 2 by 3. So this gives us confidence. So support gives us the frequency of the rule, and confidence gives us the percentage of events containing A which also contain B. That's what we saw here. So confidence is more like estimating condition probability of B given A. So problems with support and confidence. So we'll look at one example and we'll find out what is the problem with this. So you see their total number of students are 5,000. You look at this: basket, no basket; cereal, no cereal. So basketball means the among all the students, how many of them play basketball? So actually 3,000 of them play basketball. Out of these 3,000 players, how many eat cereal? 2,000. How many don't eat cereal? 1,000. And how many students don't play basketball? So 2,000 students don't play basketball, right? Out of these, how many eat cereal? 1,750. How many don't eat cereal? 250. So total number of students eating cereal is this, right? So 3,750, 75% of the student eat cereal, and 25% of the student don't eat cereal. This is what this table is all about. So number of students 5,000, basketball players 3,000, players eating cereal, total players eating cereal, that means basketball players eating cereal 2,000. So we want to calculate the support and confidence of basketball players being antecedent and eating cereal being consequent. So we get 40%, 66.67%. But overall students are eating 75% of the cereal, and this confidence is less than this. That means based on this rule, we are not going to benefit, because this confidence number, what we are trying to do is, if the basketball, how many of the basketball players are eating cereal, right? That is what the confidence will give us. Only 66% of the basketball players are eating cereal, right? That means but the overall number of students who are eating cereal is 75%. So this is greater than this. That means we cannot form a rule and then sell cereal to basketball players. We cannot say, okay, look at this. This number is so high, so let's sell cereal to basketball players. So it doesn't work that way, because that's where the problem is. When the confidence level becomes lower than the overall percentage, then it is of no use. Had it been like 90% here, then we could have said, see, 90% of the basketball players are eating cereal. So cereal is sold more among basketball players. So there is a relation between basketball and cereal, but it doesn't make sense because this is less than this. So this rule may not even be correct. Here confidence is 66.67%, right? So now we look at the other rule. Basketball player not eating cereal, right? So if you look at this particular rule, this is more accurate rule. This accurate rule is not so accurate because it has the overall percentage is higher than the confidence. Here the overall percentage of students or basketball players, of the student who are not eating cereal is only 25%, while the total percentage of basketball players who are not eating cereal is 33%. So this is higher than this. So then this rule is better than this rule because it's more accurate. So here confidence is 33.3%, right? So this is higher than this. So therefore this rule is more accurate and this rule is not so accurate. So confidence does not consider overall data. This is the problem with the confidence. So other measures, lift. There is another measure. So support and confidence, we saw some problem with the confidence. So there are other measures as well. One of them is called lift. Lift is defined as support of AB divided support of A into support of B. That means conditional probability of B given A divided by probability of B. This is the formula. Again, we are looking at the same example here. So we did calculate this rule, right? 40-60. Basketball players eating cereal. Then the lift, based on this formula, we calculate. So lift is 0.89, right? Now we calculate the lift for this one, the other rule, basketball players not eating cereal. So the lift is support is 20%, confidence 33.3%. The lift value is 1.33%. How do we interpret this? Only if lift is above 1, then we can say that two events have dependence on each other. So here we can say that these two are dependent. But here the lift value is less than 1, so they are not dependent. So earlier also we saw that this rule performs better and more accurate than this rule. So lift considers both overall data set as well as confidence of the rule. While confidence only considers the support, right? It doesn't consider overall data, while lift does consider overall data. But there is a problem with lift as well. The rules which are 100% of the time correct may not have the highest lift values. That is also a problem. If you look at some examples, although 100% of the time the rule is correct, but the lift value would be like 1.1, 1.2. So it's hardly higher than 1, right? So that is one problem with the lift. Another problem with the lift is it's symmetric in nature. So like we saw this example here, right? So best basketball player is in the antecedent and no cereal is consequent. So it gives you this value, right? But if you reverse this, you make this antecedent and this consequent, it will still give you the same result only. So this becomes a problem in analysis. So there's another measure, it is called conviction. What conviction basically does is it shows us whether our rule is valid or not. It's more like validating, what if the rule is incorrect? What are the implications, So conviction has a formula: support A, support B bar, right? So B bar would be 1 minus B, right? Something like that. So it turns out to be this formula: probability of A into probability of B bar divided by probability of A B bar. So of course probability of B bar would be 1 minus probability of B, and then this turns into this formula. So just see the formula. And So again, we look at the same example we saw earlier, right? And we calculate the conviction value for both the rules. So for the first rule, we got the conviction value is 0.75, and for this one, it's 1.125. So how to interpret the conviction? See, basically what it does is it looks at the ratio between expected incorrect, observed incorrect. What it means is the probability of expected frequency of x without y, and when x and y are dependent, divided by the observed frequency of x without y, right? So and then it calculates. So when the conviction value is 1.10, what it means is that the rule would be incorrect 10% time or 1.1 times more often if the association xy is purely random. So there are two ifs here. One is that if the value is 1.1, if it is more than 1, and if the association is purely random, that means they are not dependent on each other, then how to interpret this? Then it means the rule would be 10 times 10 incorrect 10% or 1.1 times more often than it should be. Then third is that it's a measure of implication. As we said, we are looking at the implication. What if the rules are random? If the rules that we have defined are not correct, what if the occurrences are random? And if the value is 1, then in that case, the items are completely unrelated. So this is what. And if the values are more than 1 here, and if the values if the occurrence are random, then this is how you interpret it. So then sequence mining is one important tool in method in market basket analysis. So in that we see certain things. How do we analyze the data? So we look at what items are being purchased together, right? So these are the rules we follow. Then order in which people are purchasing the items, right? Then transactions may have certain details such as customer ID, transaction ID, items list and stuff. So basically we are looking at the transaction for the sequence mining. And then two different transactions can never have same customer ID and transaction item, right? Transaction time, sorry. So that's why these two details are also important, because if you want to differentiate between transaction 1 and 2, they may have same item list, but customer ID and transaction time would always be different. Then we never consider the quantity of an item sold in a transaction. What we are more concerned about is whether the item sold or not, whether these items were purchased or not. That is what we are. How many they were sold, we are not. We are least bothered about it. So I've just given some sample code here for you to understand how to do in R. So reading and understanding data. So there is one library called A rules. Okay, so this package you can install on your R. And so how to read data? So this is read.transaction. This is a function of A rules. So I've just picked up one file, grocery.csv, which has all the transaction details, and then duplicates to, yeah, true if they're duplicates. Maybe they appear duplicate, right? But they may not be. And format is like basket. So we are reading the data as basket, right? So what happens is when you read the data, you will get the ID, the row number this side, two values actually, two columns, the rows, and in the second column you'll get in the brackets all the items sold in each transaction. So that is what it will give you. So in a curly braces you will get all the items for each row actually. And then length will give you that how many observations are there. That means how many rows in the data. Size will give you in each transaction how many items are sold, right? So number of items in each observation, that's what it will give you. Now we generate the rule. First we read the data and then we analyze the data. Now what we do is we create a rule. So a priori is a function in this package. So you provide the data here, parameters like list. So what this does is support is, that means all the values which have got support less than 0.009 will not be eliminated. Only those values, those observations which have got support value point equal to this or more will be included in this rules. And the same goes with the confidence. Only if the confidence level is 0.5 or above, only those rules will be included. Max len means only maximum three items in that rule. In antecedent and consequent together, it should only be three items, not more than that. So inspect. So inspect is a function. So just to see these rules, and you can go through. It will show you those values right in different rows. So you'll have those antecedent, consequent, then you have support values, then you have confidence values, and those details will be there. So what you do is now we want to sort the data by either support or confidence. So here we have supported in a descending order. So it will arrange all the rules in a descending order based on confidence. Actually, this is what it will do. Then again, you can inspect this new rule and you will get to see that. So if you want to control the output rules, so there are again same function. What you do is in parameters you provided. This is also controlling factor only, but how does this appear? So this will control the appearance. So LHS, so on RHS you'll have whole milk. So we want only whole milk in the consequent. That is the rule we are defining here. See, if you just provide the number of length, that means on the right side you can also have other items, right? But we on the right side, that means in consequent we only want whole milk, and the left side could be anything. That's what it means. So there is another package called A rules sequence. So this also allows you to read data which are in sequence order, right? So and with the sequence ID and event ID, and you can convert this into a data frame. Then they have here a rule. This is a function that defines this. Association rules. C is paid, and then you provide the data, then parameter support, and then it will create that kind of thing. And you can again read that in a data frame format. So thank you so much for going through this basics on market basket analysis, association rules. So these are all basics. You can do more research and learn more about it. It is used even in recommender system, like even on online. Market basket is not only used in association rule, is not only used in transaction retail business, also online business it is used, like web pages and those things, on selling items, like on, if you look at Amazon or other portals, e-commerce portals, they are also in a way retail, but it's online retail, right? So they can also use the, so they do use these market basket analysis or association rules to create recommender system. So it's very useful. So thank you again, and if you like this video, like, share and subscribe.